Oh, wait. Yeah, sorry, kitty. Yeah, that was a squirrel eating some cereal. Let's give this another try here. Hang on. Okay. All right. Hey there, everybody. So, another short video lesson. And today what we're going to do is we're going to be doing some hypothesis testing, or at least the start of how we would do hypothesis testing using Excel. Now, a couple things to note before we start here. First of all, please note that this is just the very most basic introduction to hypothesis testing. Nothing that we're going to do in this video should be considered as doing serious statistics or really proving anything. So with that in mind, all around us here is an Excel page with some data that I've downloaded. All right, so going over here to this first column, well, first of all, these are dates, right? So we've got data here that I've downloaded from January 2002 through the most recent available data, which is well into 2020. In the B column here is disposable personal income. So this is after tax, essentially after tax income of households. And in the C column here, we've got personal consumption expenditures. So household consumption spending. Now, both of these have been adjusted for inflation. They're both real, and they're both monthly data covering the same time period. Household consumption is equal to some idea of autonomous spending, some spending we couldn't explain, plus C1, which was our marginal propensity to consume, times the quantity Y minus T, which was our incomes after taxes, or T for taxes, right? Okay, so this idea here, right? And we were saying that household consumption would be explained by household income, and that the two things would be positively correlated. And then we had these behavioral variables here, C0 and C1. And we said, in the textbook and in the instructional videos that, those are the things we have to estimate. So what I've done here is gone ahead and estimated those. All right, so how would we do that? Well, we grab this column, right, or this column, and we want to grab onto the data section here, right? And then this will open up something like this, analysis tools, and you want the analysis tool pack. And then what you're going to do is you're going to specify regression analysis. And what regression analysis is, very briefly, is a way of trying to figure out how much of a given variable can be explained by other variables. Here, we're saying that income impacts or influences household consumption, right? That's the variable Y there and the variable C. And so what we're going to do is we're going to regress household income after taxes. So we're going to have to get rid of that T element in our income data. Our after-tax income explains consumption. So we're going to ask Excel to tell us how well this variable here is explained by this variable here. Okay, when I go in here to data analysis and I grab regression, right? I go okay. You can see the last one I did here. Okay, our Y range, this is the variable we want to explain. So we're trying to explain household consumption, so I'm asking it to grab from the C column. And the X range is what I'm trying to explain by, right? And so that's over here. And we can do multiple regression so for those of you, well, if you know what regression is, this video is probably too rudimentary anyway. But you can do multiple regression in Excel too. So if you have more than one variable, you can do that too. You just have to enter the whole range in here. All right. So these are the variables that I want to try to see how well they explain this variable. I've asked it to put the output here, right? Now, in fact, I've done it 3 times. I've asked to put the output here for all years. So I've ran all this from 2002 through 2020. And then I ran all but the last 20 months because, it's been kind of strange times. So I wanted to see how much our results would change if I just eliminate the last, couple of years. And then finally, I ran just the years 2002 to 2006 to see how much it would change there. And we'll see. Okay, so we get these various output tables when we do that, and these are telling us now about how these variables relate to each other. Well, here, R squared tells us how much of our variation in our Y variable, that's consumption in this case, is being explained by the X variable. Okay, so in this case, this regression output is suggesting to us that 90% of our variation in consumption spending can be explained by changes in income. Okay, adjusted R-squared tells us some things about whether our variables are really good choices or not. It's beyond the capacity of this video. Suffice it to say, at this rudimentary level, what you don't want is you don't want big changes between those two. If you see like one's 90 and one's 80, you have a big problem, right? Something's really wrong there. Okay, we have standard error here, which just tells us sort of how broad our estimate is. Then we have some other information here about how many variables we've included, how big our data set is, and then down here is the last thing that we really want to make sure to get into, our intercept right here, 2156. Okay, well, what is that? That's where our zero value for our x variable is estimated, or that is essentially our estimate of C0. Okay. Then we have our x variable 1 here, 0.72. That is our estimation of C1 based upon this data. And C1 is 0.72. Okay, so that's actually a result that kind of makes sense with what what the theory kinds of tells us here, right? Okay, now again, as I said in the beginning, we want to this is not serious science here for a lot of reasons, right? This is just an introduction to the tools that Excel has, and really even Excel's regression analysis tools are pretty basic. It'd be far better to use a better software package like SPSS or SAS or eViews or R. There's a lot of them out there. Okay, so then I thought, okay, well, the last 20 years were kind of strange, so what if I just get rid of like the most recent data and see if I get a better explanation? And sure enough, my R-squared hops up to 0.98. So now I'm explaining 98% of my variation in consumption spending by changes in income, right? So we do have a nice consistent answer here now, 0.81. So it's greater than the other one, right? But it's still within the range of what we would normally think. But we want to note here that these results are significantly different, which that shouldn't be. If we're doing good science here, if we're doing good statistical analysis, and that thing's moving around that much, something's wrong. We need to go back and figure out what's wrong in our model and in our explanation. But we do have enough information to say that we're kind of on the right track here with this. We're not talking crazy talk right now. And we can get these results, right? And like I said, this is enough for us to kind of get the idea that, well, we're kind of on the right track here, but our model really isn't sufficient to draw any hard conclusions from, right? We haven't proven anything here, but we've done a lot more than nothing. So, final note: all this data is just pulled from the FRED site, so the St. Louis Federal Reserve Economic Database, right? So I just downloaded this data, then I downloaded this data, put them together, and then ran the regression analysis in Excel. All right, that's plenty enough for this time. Thanks, everybody. We'll see you again soon next time. Take care.